Good morning, students. In the previous session, we have seen electropotential, electromotive force, and electrochemical series. So just let us recall those three topics. After that, let us start today's session. Electrode potential is nothing but it is the potential of a single electrode. That means either for anode or the cathode. Electrode potential is nothing but it is the potential difference between it is the potential difference between electrode and its salt solution. For example, if you are taking zinc is an electrode, its own salt solution is zinc sulfate or zinc chloride or zinc chloride. That means the salt solution must be containing that particular metal. If copper is the metal, copper sulfate or copper chloride is the electrolyte. That is the own salt solution. So when the metal is dipping in its own salt solution, there develops potential. That potential difference is called electrode potential. So electromotive force is nothing but it is a cell potential. Cell potential is nothing but it is the potential of two electrodes. Because cell is consisting two electrodes, namely anode and the cathode. So your cell potential or electromotive force is nothing but it is the potential difference between two electrodes. We have seen the formula in the previous class. EMF or E cell is equals to E cathode minus E anode. That is electromotive force. And electrochemical series is nothing but it is a series of the metal. It is the arrangement of metals on hydrogen scale in the decreasing order of reduction potentials or in the increasing order of oxidation potentials is called electrochemical series. In electrochemical series, the top metals always acting as the anode, bottom metals are acting as the cathode. Top metals are the active metals and the bottom metals are the inactive metals. That is electrochemical series. Now let us see the next topic in the today's session, that is electrochemical cells. But before that, you know what is cell? Cell is containing two electrodes, anode and the cathode. So now let us see the introduction of electrochemical cells. An electrochemical system is comprised of a vessel containing an electrolyte into which two electrodes are dipped. That means every electrochemical system is containing a beaker or vessel. So this vessel is containing an electrolyte. So this electrolyte may be in the liquid medium or in the semi-solid medium. Semi-solid is nothing but the paste form. In this electrolyte, we are dipping the two electrodes. That is the construction of electrochemical cell. Now these two electrodes are connected by the first class conductors. That means that two electrodes must be the best conductors of electricity. And these are connecting with a source of electrical current. So how these two electrodes are connecting? These two electrodes are connecting with the help of electric source. So what is the electric source here? Battery or the ammeter is the source of electric current. During electrolysis process, chemical reactions of ions occur at the electrodes due to the passage of electric current. So when the two electrodes are connecting with the help of battery and when the battery starts working, what happens? Here the chemical reactions takes place in the electrolyte. That means electrolysis takes place here. But here we are having various types of cells, not various types of cells. We are having two types of cells based on the conversion of energy. Just let us recall the first class. In the introduction of electrochemistry, I explained you that electrochemistry is the branch of physical chemistry which deals about the interconversion of electrical energy to chemical energy and chemical energy to electrical energy. Yes. So what electrochemistry is studying? It is studying the interconversion of electrical energy to chemical energy to electrical energy. So in the first case, electrical energy converts to chemical energy. That means by consuming electricity, chemical reactions takes place. Whereas in the second case, chemical energy converts to electrical energy. That means due to the chemical reactions, electricity is producing. So based on those conversions, electrochemical cells are classifying into two types. So those are electrolytic cell and the galvanic cell. In an electrolytic cell, a flow of current produces a chemical reaction. What is the electrolytic cell? A flow of current produces chemical reactions. That means due to the flow of current, chemical reactions takes place in electrolytic cell. That means electrical energy converts to chemical energy. Flow of current produces chemical reaction. That means current converts to chemical energy. Current is nothing but electrical energy. Chemical reaction is nothing but chemical energy. So here in electrolytic cell, electrical energy converts to chemical energy. Whereas in a galvanic cell, electric current is generated in consequence of chemical reactions proceeding all the electrodes. That means here electric current is generated. That means electrical energy is generating here in consequence of chemical reactions proceeding at the electrodes. That means, so due to the chemical reactions, electricity is producing in galvanic cell. That means in electrolytic cell, electrical energy converts to chemical energy. In galvanic cell, chemical energy converts to electrical energy. An electrochemical cell is a device capable of either generating electrical energy from chemical reactions or facilitating chemical reactions through the introduction of electrical energy. So what is electrochemical cell? Either electrical energy converts to chemical energy or chemical energy converts to electrical energy. An electrochemical cell consists of two half cells. Each half cell consists of an electrode and an electrolyte. Yes, so this cell is consisting of two half cells. I explained you in the previous class what is mean by the half cell. Half cell is nothing but in the cell half of the part. That is mean by the half cell. So here each half cell is containing electrolyte. Yes. So that is we are explaining here the two half cells. Each half cell consisting of an electrode and an electrolyte. The chemical reactions in the cell may involve the electrolyte, the electrode, or an external substance. So in the chemical reactions, what are involving here? Electrolyte, electrodes, and some external substances. In a full electrochemical species, from one half cell lose electrons to the electrode, while species from the other half cell gain the electrons. Yes, so in the previous class we have seen at one electrode electrons are losing and in the another electrode electrons are gaining. So here one half cell is losing the electrons and another half cell is gaining the electrons. So now what you understood here? Here we are having two types of cells. One is electrolytic cell and the galvanic cell. In electrolytic cell, electrical energy converts to chemical energy. In electrochemical cell, chemical energy converts to electrical energy. And here, the cell is containing two half cells. One half cell is undergo oxidation, other half cell is undergo reduction. So now let us see the next one. And it is also containing a salt bridge. Salt bridge is often employed to provide ionic contact between two half cells with different electrolytes and prevent the solutions from mixing and causing unwanted side reactions. So how the salt bridge is connecting, that I will explain you in the next slide. So how the salt bridge is connecting? The salt bridge is connecting with the help of two beakers. Yes. So in the two beakers, we are taking the electrolyte, the liquid we are taking. So in these two liquids, we are dipping the salt bridge. So what is the use of salt bridge? To provide ionic contact between two half cells. So it is avoiding the contact, direct contact between the two half cells with different electrolytes and preventing the solutions from mixing. So if you are taking the two electrolytes to do two different electrolytes in the same beaker, what happens? These two electrolytes will be mixing. So to avoid the mixing of the two electrolytes, we are using the salt bridge. And this salt bridge helps to the chemical reactions. That means to transfer the electrons from one electrode to another electrode, the salt bridge is useful. An alternative to a salt bridge is to allow direct contact between the two half cells. So to avoid the intermixing of the two electrolytic solutions. Also, it allows the flow of negative or positive ions to maintain a steady state charge distribution between the oxidation and the reduction vessels. That means it is also helping to transfer the electrons or ions from one electrolytic solution to the another electrolytic solution. That is the use of salt bridge. So now let us see the classification of electrochemical cells. Electrochemical cells are classifying into two types. One is electrolytic cell and the galvanic cell. Galvanic cell is also called as the voltaic cell. Electrolytic cells are those in which electrical energy electrolytic cell in which electrical energy from an electrical source causes non-spontaneous chemical reactions to occur. That means here in which electrical energy is consuming and it is producing the chemical reactions. Those are the non-spontaneous chemical reactions. But before that, what is meant by the spontaneous and the non-spontaneous? Here you are having the non-spontaneous chemical reactions to occur. Yes. So what is meant by the non-spontaneous chemical reactions here? Non-spontaneous is nothing but which is done by the external force. It is not done itself. Yes, spontaneous is nothing but the natural process, but non-spontaneous process is nothing but the artificial process. So whatever the cells, electrolytic cells are there, those electrolytic cells are artificial process. That is not the natural process here. So here artificially what is happening here? We are supplying electricity. By supplying electricity, only the chemical reactions takes place here. So that is electrolytic cell. Whereas in a voltaic cell are those in which spontaneous chemical reactions are produced by consuming electricity and supply it to an external circuit. Yes. So what happens here? It is happening naturally and spontaneously. Spontaneously, chemical reactions are produced by consuming electricity. By consuming electricity, the chemical reaction, by doing chemical reactions, electricity is producing in the voltaic cells. Both types of cells containing two electrodes connecting to an external circuit that provides an electrical connection between systems. So both types of cells, whether it is electrolytic cell or voltaic cell, whatever the type of cell, both types of cells are containing two electrodes, anode and the cathode, and these two electrodes are connecting with the help of external circuit. That means the source of electric current. When circuit is closed, electron flow from the anode to the cathode. Electrodes are connecting by the electrolyte, which is an ionic substance or solution that allows ions to transfer between the electrodes, thereby maintaining the system's electrical. Yes. So that is electrolytic cell and the voltaic cell. So now let us see the construction of electrolytic cell and the voltaic cell. How to construct and what is the working condition of the electrolytic cell and the galvanic cell. So first let us see the electrolytic cell. This is electrolytic cell. In electrolytic cell, non-spontaneous chemical reactions are forced to occur by the input of electrical energy. This process is called electrolysis. So what happens in electrolytic cell? Electrical energy converts to the chemical energy. That means non-spontaneous chemical reactions are produced due to the consumption of electricity. An electrolytic cell consists of two electrodes, an electrolyte and external power source. See here, this is cathode, this is anode, that means two electrodes, and this is the battery. So the battery is connecting with the help of anode and the cathode, and this is electrolyte. So in this we are taking only one electrolyte. In one electrolyte we are dipping the two electrodes. These two electrodes are connecting with the help of battery. So the migration of ions in the solution is an electrical current. So here migrating of ions in the solution is the electrical current here. So here ions are migrating. So when the two electrodes are connecting with the help of battery, now the electricity starts passing here. So after passing the electricity, what happens here? The electrolyte, whatever the electrolyte we are taking, that electrolyte starts decomposing. So when electrolyte is decomposing, breaking, it is giving the cations and the anions. Yes. So this cation moves to one electrode, anion moves to another electrode. But now we need to know what is the charge of cathode and what is the charge of anode. Yes. In electrolytic cell, anode carries positive charge, cathode carries negative charge here. In electrolytic cell, anode carries positive charge, cathode carries negative charge. But whereas in voltaic cell or in galvanic cell, the charges are opposite. That means anode is carrying negative charge, cathode is carrying the positive charge. So now we know anode is having the positive charge, cathode is having the negative charge. So when electrolyte starts decomposing, we will get the cations and the anions. These cations goes to the negative electrode, anions goes to the positive electrode. Cation means positive ion, anion means negatively charged ion. So this cation goes towards cathode, which is negative electrode. The negatively charged ions, that means anions, are moved towards anode, that means the positive electrode. So in electrolytic cell, anode carries positive charge, cathode carries the negative charge. So electrodes are surfaces on which oxidation or reduction half reactions occurs. So here we have seen the cathode and the anode. So which ions are moved towards anode? Anions. That means negatively charged ions moves to the anode. Positively charged ions are moved to the cathode. So what is mean by the positive? Positive is nothing but electron deficiency. Negatively charged is nothing but excess of electrons. Just remember this. I will explain this in the next slide. See here, electrodes are surfaces on which oxidation or reduction half reactions occurs. They may or may not participate in the reaction. Those that do not react are called inert electrodes. So whatever the electrodes we are taking here, those electrodes are not participating here. Instead of participating electrode, electrolytes are participating in the reaction in electrolytic cell. So whatever the electrodes are not participating in the reaction, those electrodes are called inert electrodes. Those electrodes are called inert. Inert is nothing but which is not reacting. The external power source acts as an electron pump. The electric energy is used to do work. The external power source acts as the electronic pump. The electrical energy is used to do work on the electrons to cause an electron transfer. So here due to supplying electricity, electrons are transferred from one ion to another ion, or one ion to another ion. Electrons are transferred. Electrons are pulled from the anode, pushed to the cathode. So what is meant by the pulled from the anode? So it is removing from the anode and pushed to the cathode. It is electrons are moving towards the cathode and throwing from the anode. Yes, that means at anode electrons are losing. That is meant by the oxidation. At cathode electrons are gaining. That is meant by the reduction. Yes. So electrons are pulled from the anode. That means at anode electrons are losing and pushed to the cathode. That means the cathode, at cathode electrons are gaining by the battery or power supply. So what happens here? In electrolytic cell, whatever the two electrodes we are taking, those two electrodes are not participating in the reaction. But here, whatever the electrolyte we are taking, that electrolyte is decomposing here and producing cations and the anions. So see here. So regardless of the kind of cell, electrolytic or voltaic, the electrodes are identifying as follows. The cathode is defined as the electrode at which reduction occurs as electrons are gained by some species. The anode is the electrode at which oxidation occurs as electrons are lost by some species. So what is happening at cathode? At cathode, reduction occurs. At anode, oxidation occurs. At cathode, electrons are gaining. At anode, electrons are losing. So here we have given one example. So copper, oxidation means loss of electrons. See here, copper is losing 2 electrons to produce copper plus 2. And here Zn plus 2 is gaining 2 electrons to produce Zn. That means it is undergo reduction. Reduction means gaining of electrons. Oxidation means loss of electron. Oil, that means oxidation is loss of electrons. Rig, reduction is gaining of electrons. So each of these can be either positive or the negative electrodes. In electrolytic cell, anode is positive while cathode is negatively charged. In galvanic cell, anode is negative while cathode is positively charged. Yes. So you must remember this point. In electrolytic cell, anode is positive, cathode is negative. And whereas in galvanic cell, anode is negative while cathode is the positively charged. So now let us see the diagram of electrolytic cell. So this is example of electrolytic cell, electrolysis of molten sodium chloride. So here these are the two electrodes. We are taking two inert electrodes. So these are the platinum electrodes. So these two are the platinum electrodes. These two platinum electrodes are the inert electrodes. You know what is meant by the inert electrode? Inert electrode is nothing but which is not reacting in the reaction. So the two electrodes are connecting with the help of battery. And now we are taking sodium chloride electrolyte. But when the two electrodes are connecting with the help of battery, the electrolyte starts decomposing. When electrolyte is decomposing, it is producing Na plus and Cl minus. Na plus and Cl minus. But we know what is plus, what is minus. Plus is deficiency, minus is excess electron. If we have plus 1 electron deficiency, plus 2 electrons deficiency, plus 3 electrons deficiency. Minus 1 means 1 electron excess, minus 2 electrons excess, minus 3 electrons excess. So see here we are having Na plus 1, that means 1 electron deficiency. And here Cl minus. So Cl minus is nothing but 1 excess electron. So what happens here? When the electrons are excess, what happens? It will remove the electrons. So see here at anode, the Cl minus is losing 2 electrons to produce Cl2. because 2 Cl minus ions are participating here. In 2 Cl minus ions, 2 electrons will be excess. So by losing 2 electrons, it is producing Cl2. But whereas in Na plus, 1 electron deficiency is there. So these electrons are transferred to Na plus to produce Na. But here how many electrons are released at anode? 2 electrons. So the same 2 electrons are transferred to Na plus. So that means 2 Na plus 2 electrons giving rise to 2 Na. Yes. So that is the reaction at cathode. So at anode, electrons are losing. At cathode, electrons are gaining. So now this is the overall cell reaction. So how to get overall cell reaction? By adding these two reactions. By adding these two reactions, we will get overall cell reaction. Now we are adding reactants and the products. So what are the reactants here? Na plus electron. But I said now 2 Na plus 2 electron giving rise to Na. And here 2 Cl minus giving rise to Cl2 plus 2 electrons. Now add these two reactions. 2 electrons gets cancelled. Now add the reactants and the products. Na plus 2 Cl minus is the reactant. 2 Na plus 2 Cl minus is the reactant. 2 Na plus Cl2 is the product. So adding reactants and the products. Yes. So what is happening in the electrolytic cell? By supplying electricity or by consuming electricity, these chemical reactions takes place at the electrodes. That means at electrolyte. Yes, that is the electrolysis of NaCl. So see how these are migrating here. So this is at the microscopic level. Cation migrates towards negative electrode. So these are cations. Cations are moves towards negative electrode. Anions moves towards positive electrode. Cations moves towards negative electrode. Anions moves towards the positive electrode. Yes. So this is at the microscopic level. So now let us see the next type of cell, voltaic cell or the galvanic cell. Voltaic cell or the galvanic cell. So galvanic cell is nothing but the cell which converts chemical energy to electrical energy. So in voltaic cell or galvanic cell are electrochemical cells in which spontaneous redox reaction produce electricity. That means due to the redox reactions, electricity is producing in the voltaic cell. So you know what is meant by the redox reaction? Redox reaction is nothing but oxidation and reduction reaction. So due to spontaneous oxidation and reduction reaction, electricity is producing in the voltaic cell. In all voltaic cell, electrons flow spontaneously from the negative electrode to the positive electrode. So in a voltaic cell, electrons are migrating very fastly from the negative electrode to the positive electrode. But what is the negative electrode here? Anode is the negative electrode, cathode is the positive electrode here. And composed of two separated half cells, which each consist of a metal rod or strip immersed in a solution of its own ions and inert electrolyte. So here it is containing the two half cells. Whereas in electrolytic cell, see here, in this, we are not having half cells. Here we don't have any half cell because half cell is nothing but when electrode is dipping in its own salt solution. In this we don't have the half cell. But whereas in voltaic cell, we are having the two half cells. Two half cells are nothing but one electrode is dipping in its own salt solution, other electrode also dipping in its own salt solution. So like that we are having two half cells in voltaic cell. The electrodes are connecting by wire and the circuit between the two cells is completed by salt bridge. So here the two electrodes are connecting with the help of battery and the two electrolytes are connecting with the help of salt bridge. The electrons flow from the anode to the cathode through an electrical circuit rather than passing directly from one substance to other. So why we are using the salt bridge here? The salt bridge is helpful to transfer the electron from one electrolyte to another electrolyte through external circuit. Yes, so it is useful like that. So this is the construction of galvanic cell. Yes, so here see, zinc rod is dipping in the zinc sulfate, copper rod is dipping in the copper sulfate. Now the zinc rod and copper rod, these two are connecting with the help of battery or the electrical source. Now the two electrolytes are connecting with the help of salt bridge. Yes. So how we can say that zinc is anode and copper is cathode? On the basis of electrochemical series. I said you in electrochemical series, the top metals always anode, the bottom metals always cathode. So here zinc is in the top position in electrochemical series. So zinc is acting as an anode. And copper is at the bottom position in electrochemical series. So copper is acting as a cathode. But why we are calling this as a half cell? Because electrode is dipping in its own salt solution. Zinc, zinc sulfate, copper, copper sulfate. So it is dipping in its own salt solution. So it is called as a half cell. Anode half cell, cathode half cell. But see here, the zinc is losing the electrons. Zinc, because it is anode, at anode electrons are losing. Zinc is losing 2 electrons to produce Zn plus 2. These 2 electrons are transferred to the cathode through the external circuit. See here, the electrons are transferred from here to here through the external circuit. But here the Cu plus 2 ions in the electrolyte. If charge is there, that is electrolyte. If there is no charge, that is electrode or the metal. So now here Cu plus 2 ions in the electrolyte are gaining the 2 electrons to produce Cu. Yes. So that is electrochemical cell or the galvanic cell or the voltaic cell. Yes. So this is the diagram of the galvanic cell. So now let us see what are the reactions takes place again. Zinc is losing 2 electrons to produce Zn plus 2. Copper plus 2 is gaining 2 electrons to produce copper. Now this is oxidation half reaction. This is the reduction half reaction. Now by adding these two reactions, we can write overall cell reaction. So overall cell reaction is nothing but by adding these two reactions. By adding these two reactions, we need to add the reactants and the products. So if you add the reactants, 2 electrons gets cancelled. Zn plus Cu plus 2 giving rise to Zn plus 2 plus Cu. Yes. So now let us see how to write the cell notation. This is the cell notation. So this is the general cell notation. Anode, anode electrolyte, double vertical line, cathode electrolyte, cathode. That means anode is dipping in the anode electrolyte, cathode is dipping in the cathode electrolyte. Here double vertical line is nothing but the salt bridge. Double vertical line is nothing but the salt bridge. Now here anode is zinc in our voltaic cell. Anode electrolyte is zinc sulfate. Double vertical line. Cathode electrolyte is a copper sulfate. Cathode is a copper. So here the single vertical line is nothing but it is contacting with the particular electrolyte. A double vertical line is resembling the salt bridge. Yes. So this ZnSO4 also can be mentioned as a Zn plus 2. CuSO4 also can be mentioned as a Cu plus 2. Yes. So already I said now, if we have the charge, that is electrolyte. If there is no charge, that is solid, that is the electrode. Yes. So this is the cell notation of the galvanic cell. So now let us see the last topic in today's session. Let us see the differences between electrolytic cell and the galvanic cell. In this slide, we are having electrolytic cell, and in the next cell, we are having the galvanic cell. So the first point in electrolytic cell. So you tell me what are the differences between electrolytic cell and a galvanic cell. In electrolytic cell, electrical energy converts to chemical energy. In electrochemical cell, chemical energy converts to electrical energy. In electrolytic cell, anode carries positive charge, cathode carries negative charge. In galvanic cell, anode carries negative charge, cathode carries positive charge. And now it requires EMF. That means the external source is required in electrolytic cell. Without connecting anode and cathode to the external circuit or the external source, there is no chemical reactions in electrolytic cell. So here it requires EMF. But whereas it produces EMF, that means it is producing electricity in galvanic cell. Electric energy is converted to chemical energy in electrolytic cell. But here chemical energy converts to electrical energy. Anode is positive, cathode is negative. But here anode is negative, cathode is positive. Oxidation takes place at anode, reduction takes place at cathode. Here also anode is negative, cathode is positive. Oxidation takes place at anode, reduction takes place at cathode. That means whatever the type of electrode, whether it is electrolytic cell or electrochemical cell, always at anode oxidation, always at cathode reduction reactions takes place. But only the sign is opposite. Discharge of ion occurs at both electrodes. Yes. So here ions are moving from the electrolyte to electrode. There is a discharging of ions from electrolyte to electrode. That means the both electrodes are participating in the reaction. But here discharges of ions occurs only at cathode. Yes, but not at anode. At anode simply electrons are losing. But whereas at cathode the Cu+2 ions are involving here. The ions are involving at cathode. So only at cathode ions are involving here. Non-spontaneous reactions occur. These are irreversible. So whatever artificial process, the artificial process are not reversible. Those are irreversible processes. Yes. So this is a non-spontaneous reaction. Non-spontaneous is nothing but the artificial process. But this is a spontaneous process. This may be reversible. Flow of electrons is from anode to cathode. And here also the electrons from anode to cathode. Because always at anode oxidation, that means loss of electrons. At cathode gaining of electrons. Whatever the electrons are losing at anode, those electrons are gained by the cathode. So always electrons are transferred from anode to cathode. Electrons leave the cell at anode and enter cell at the cathode. Same thing happened in the galvanic cell also. Electrons leaves the cell at anode and enter the cell at the cathode. So only three differences are there. There EMF is consuming, here EMF is generating. And there electrical energy converts to chemical energy, here chemical energy converts to electrical energy. And there anode carries the positive charge, cathode carries negative charge. But here anode carries negative charge, cathode carries the positive charge. And one more difference. There the process is the non-spontaneous, but here the process is the spontaneous process. So thank you so much. The remaining we'll see in the next class.